Hey folks, welcome to the video. Today we will be solving October 2nd Leetcode challenge, Leetcode daily challenge. But before jumping into that, we haven't discussed the time complexity and space complexity of the yesterday's problem. So we will look first about that and we will discuss this, and after that we will move on to today's video. So yesterday we have coded the solution together, and to find the space complexity, it's fairly easy that we are using only one this consumed variable and empty variable, and none other variable we have defined. So uh, space complexity is of 1, and to find the time complexity we have to find how many times we are running this while loop. So this while loop is running until this number of bottles is greater than 0, which you may say that number of bottles is, in example, like n. So you will say that it's O of n, but it's not actually O of n. I will explain why it's not O of n. So every time we are reducing number of bottles by empty divided by number of extensions. Okay, so this is reducing our number of bottles drastically, so that's why it's not number of bottles. So you can assume that in empty cell we always have that number of bottles plus from previous empty cell we have some left. So we can fairly assume that number of bottles we are reducing by number of exchanges time each time. Like for example, it's 9 at the starting and number of exchanges is 3. Then we will divide 9 by 3, it will come out to be 3, and then we will divide 3 by 3, it will come out to be 1, and then 1 by 3, it will come out to be 0. So we are reducing by that each time. Okay, so it's not taking 9 iterations, it's taking log of 9 iteration and with base 3. So we are dividing by 3, so it's base 3. So remember how we find the log of some number. We are dividing this, like for example, log of a base b is equal to number of a divided by b. Okay, and we will count how many number of iterations it till a is 0. So we will do this operation in while loop, and we will count how many number of iteration we have done, and that way we can find log of a base b. So that's why it's like log of, though for our example our time complexity will be log of number of bottles base number of exchanges. So this will be our time complexity. There is one more easy trick here, so we can find this complete answer. I have read in this editorial that we can complete this answer in O of 1 time complexity as well, but that is some like tricky trick or maths to be involved. It's not like simple simulation which we did yesterday, so we will skip that and you can read along in the editorial and solution section. Quickly we will jump on to the today's problem. So let me remove this first. Yeah, so today is second day of Leetcode challenge of October. Today's problem is water bottle 2. Interesting, water bottle 2, nice. So we'll open this. Okay, in water bottle 2 problem we have like something similar, full bottle, empty bottle looks like. Let's read this together and we will come up with some solution. Okay, you are given two integer array, two integers, number of bottles and number of exchanges, same as yesterday's problem, and number of bottles represent the number of full water bottles you initially have. In one operation you can perform one of the operation, drink any number of full water bottles, turning them into empty bottles exactly as yesterday's. Exchange number of empty bottles with one full bottle, same as yesterday. Then increase number of exchange by 1. Okay, this is a twist. In previous problem we are just keeping the number of exchange same as same throughout the problem, but here we have to increase by 1. Okay, so let's say we will divide empty bottles divided by number of exchange, we will do some full bottles, we will get some full bottles, and we will increase number of exchange by 1. After that, it's note that you cannot exchange multiple batches of empty bottles for the same value of number of exchange. Okay, so in previous example, so let's further read. Return the minimum number of, देखो for example, if number of bottles is 3, number of exchange 1, you cannot exchange 3 empty bottles for 3 full bottles, exactly what I have explained you. So return then maximum number of water bottles you can drink. Let's take some examples. So in example number 1, initially we have 13 number of bottles and we have 6 number of exchanges. So it is saying that we will consume, let's let's take a look at second example. Just a minute, this is yesterday's problem. I will copy this code and let's remove this, it's not needed now. So we have consumed as 0, empty is 0, number of bottles, whenever number of bottles is greater than 0 we will drink it, so we will go into the loop and we will return consumed at the end. So starting initially we have number of bottles, we will consume all of them. Empty bottles will be increased by number of bottles which we have consumed right now, and number of bottles will become 0. Now we have to fill up this number of bottles which is like full bottles. So the trick here is that number of bottles is empty divided by exchange, so we can't divide this, we have to increase number of bottles only by 1. So let's plus time. Okay, and this operation will be effective whenever we have number of empty bottles greater than exchanges. So if we can add one condition, if number of empty bottles is greater than number of exchanges, then we will do this number of bottles plus plus, and if it is equal then also we will do. Okay, and we will do this thing like empty bottles will become empty minus number of exchanges. These many bottles are left now, and number of exchanges will be increased by 1. Whenever we do first one exchange, number of exchange will be increased by 1. If we are not doing any exchange, then number of exchange will not be increased. So we can remove all this and let's try this. Yeah, it's accepted. No, it's like both of the test cases are passed. Let's submit this. Yes, so the solution is accepted. Now we can discuss this time complexity and space complexity of the same solution, same as yesterday. So it will be like fairly easy, it's similar to yesterday's, if I can say. Space complexity, we are not using any of the auxiliary space or any array, we are using only these two integers, so it's O of 1. And for the time complexity, we are reducing number of bottles each time, like we are completely emptying them, we are increasing by 1. Okay, we can also do while, inside while, something like we are consuming one bottle at a time, one bottle then one bottle, not like similar to this simulation. We can do simulation as well, like while empty is greater than, then we can do this. So this will increase our chances, like increase our lower our time complexity, because this is not something like while के अंदर while आ गया तो it's n square. It's simple till empty bottle is greater than number of exchanges, so we are increasing that one by one, like first exchange, doing second exchange, doing third exchange. So we will be consuming all of these exchanged bottles at once. So it will lower our time complexity. Let's submit the solution as well. Yeah, it's accepted. Now it's 0 ms, beats 100%. It's better than before. Okay, and time complexity, we can say that 8 makes its number of bottles, which is like n, and number of exchanges is m. So we are reducing number of bottles by consuming them, and we are adding number of bottles like 2 3, some bottles basically, number of exchange time. So it's number of bottle divided by number of exchanges each time, something like that. So it will be log of n by m, log of n base m, exactly similar to yesterday's, which I have explained. I hope you found this useful. You can also read through this editorial, it's open. Like approach 1 is simulation, so we are doing same as simulation, and it is saying that some simulation time complexity is under root of n, square root of n, which I have to check why that's the case. Okay, let's understand this. And second approach is mathematics. Similar to yesterday, we can do something by the formula and it will come out to be time complexity of O1. It's some tricky, you can read out the solution, but the easier approach is simulation, and this is the intuition we can come up with the instantly in interviews. So how it is saying that it's of root n, let t be the number of times we exchange number of bottles. Okay, t times we are exchanging, then the total amount reduced from empty after the t exchange is 0 to t k plus 1 k plus I minus 1, number of total amount reduced from empty is, okay, we are summing that up. Okay, equal to t of k minus 1 plus t minus 1 by 2. Okay, this is like dividing in two forms, like s of t is form of t of k minus 1. So since s of t less than equal to 1, substituting in formula, simplifying the t square, its quadratic equation, and quadratic equation upper bound of t is square root of n. Okay, I don't understand how exactly it's going, so let's leave it. If you understand this, let's comment how we can easily explain this same thing. Hope you found this useful. We will again meet tomorrow for the 3rd of October problem, which is not open yet. Let's see if both of problems is solved. Yeah. Bye guys.